Hello everybody, welcome back. Today we're continuing with 4.2, applying the sine and cosine laws for obtuse triangles. What we're going to look at now is we are going to do example 4. And it says in an obtuse triangle, angle B measures 23 degrees and its opposite side B has a length of 40 centimeters. So that's opposite angle side. Side A is the longest side of the triangle with a length of 65 centimeters. Determine the unknown measure to the 10th place. So drew a quick diagram for you. This makes this turns this knowledge question into what we call an application question, where you got to create the diagram and then go from there. And the key is it's telling you it's an obtuse triangle. It told you this is the longest side. That means that angle A is going to be greater than 90 because it's an obtuse triangle. The longest side, which it told you was 50. Therefore, you have to create a triangle that has an angle that is greater than 90. Okay, so it's very important we do that, because there's another way to make this triangle which is very interesting. So we're going to learn about that another time, but it is very interesting. So I've added all those in here. So what we're going to do is we're going to look, do we need to apply the sine or cos law? Remember, we always want to do the sine law if we can. So we know a pair, right? So we have an angle and an opposite side. So that's a good thing. That tells us we can use the sine law. And then we're looking for angle A there. So that's great. So let's go get our sine law equation. So we have the sine law. We're looking for angle A. So we're going to put the sine A in the numerator. Let's fill in what we have. So we're looking for angle A. We have side A is 65. It's decimal zero, so we can just leave it at 65. Angle B is 23 degrees, and side B is 40. Okay. So then we're going to multiply both sides by 65. Going to multiply both sides by 65. Like that. Multiply both sides by 65. The 65s are going to divide. So we have 65 divided by 65. And we get just sine A. Angle A. And we're going to do this on our calculator, and we do sine A. We're going to multiply this, and when we do that, we get, and I'll do that on my calculator here. I've showed you what to do there before, so we're going to do that now. 65, make sure your calculator's in degrees, of course. Close your bracket on the 23. Maybe I'll show this on the calculator just to double check. So we're going to put this in. We got 65 sine 23. Close my bracket, divided by, and the other side was 40. And we get 0.6349. 0.6349. 3808, and so on. So no, that's not our angle. We're not finished. So we're going to do the angle A. Angle A is equal to the inverse sine of this number here that we have in our calculator already. So the calculator automatically opens up the bracket, right? So we'll go to our calculator, we'll plug that in. So we'll go second function, sine, second function answer, which is going to take this number and put it in here for us. And we get 39.4. And I know some of you are thinking, what? What's going on here? We have angle A equal to 39.41539.241. Sir, that can't be the right angle. What do you mean? Well, this is an obtuse angle. It has to be greater than 90. Right. But if you remember from 4.1, there's two angles within 0 and 180 degrees that are equal. All right. So angle A is actually equal to 180 degrees, 180 degrees, oh, sorry about that, folks, 180 degrees. Sometimes this will drive you crazy, and I do apologize. So 180 degrees minus 39.41539.241, which equals 140.6 degrees. And it's set to the nearest tenth place. It's 584 and so on. So that's actually equal to 140.6 degrees. Now I know some people are like, whoa, what's going on here? How can that be? Remember, we did this, and that's why we did that earlier on in the chapter, and when we did 4.1. So angle A measures Angle A measures 140.6 degrees. Now I'm going to show you that in the calculator just because I know you're like, what? How can the sine of 39 and 40.54 be the same? Well, let's take a look. So we took the sine of 39.4 and we got the 0.6, which we had, just like doing a check here, and it was a sine of 140.58460.76. Close your bracket, hit enter, and it is the same. I mean, the last digit is not because of the rounding, but if you look at it, they're equivalent. And again, that is because sine of theta is equal to the sine of 180 minus theta. So your calculator will calculate the angle between 0 and 90, but you have to take that angle and subtract it from 180 to get the actual angle, which we knew was greater than 90. So very interesting. We're going to explore this more in Pre-Cal 11, but this is interesting to why this occurs. So pretty neat. So remember, when you do the sine and you get your angle for an obtuse triangle, and you know it's greater than 90 degrees, you will take 180, subtract the angle that you calculate to give you the actual angle of 140.6. Next, we're looking at example 5. This is solving a word problem using sine and or cos laws. The roof of a house consists of two slanted sections as shown. A roofing cap is being made to fit the crown of the roof. So right here, where the two slanted sections meet. Determine the measure of the angle needed for the roofing cap to the nearest tenth of a degree. So this house obviously is not symmetrical. So this roof comes down, even though it may look it, this here side is a little longer than this side, obviously by 3.3 feet. So what we're going to do is I'm going to take this triangle here and I'd like to draw another diagram just with the obtuse triangle. So here is my triangle that I've created. So I've labeled it ABC. So this is the scenario side, side, side. So we know that when we have side, 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 we're going to have to use our cosine law, of course. Okay, so what we're going to do is we're going to go get our cosine law, solving for angle, and in this case it would be angle C. So you may remember in example 3 that we use this. Remember, because we're talking C here, that just means that this, like our formula is going to be given with A at the beginning here. So we just change this A to C, change this A to lower C, and then C becomes A, and this C becomes A. So we just switch the A and B. It's that simple, okay? And then we're going to solve for angle C, because this theta up here is angle C, just based on the information that we gave. Now you can call it A. It's up to you. I just took this from the textbook, so that's what they call it. So we had to change our formula, as I shown there a minute ago, okay? So just be consistent with your changes, right? So I changed A and C. You can clearly see between these two formulas that A and C have changed, okay? And it's just because of the way they've labeled it. If you wanted to label it A, which you probably should have, it would have worked. Again, it doesn't make a difference, okay? Just have to be consistent. All right? So let's plug in what we know. We're looking for C. They've called it theta, so we'll call it theta. Again, it doesn't matter what you call it, but like I said, just to be consistent with the diagram, we'll call it theta as well. C is given as 33.5. B is given as 20.3. A is given as 17.0, and we can just call that 17, right? And the reason I don't put the decimal zero, and sometimes people get mixed up when they put 170 or they forget, whatever the case may be. So again, it's no big deal. Put our B in as 20.3 and our A in as 17. So we've substituted all of our values in for A, B, and C. Now we're going to do the squaring of each. I do these separately, so I square them. I get 33.5, which is 1,122.25. Now, once you get better at these and a little more familiar or comfortable with them, then you can do it all in one step if you want. 17 squares, well, we know that's 289. Okay, 289. Then multiply the three numbers in the denominator, -2 by 20.3 by 17, and we get -690.2. Okay, 690.2. Recopy the line. Add the three numbers in the numerator, or subtract them from 1122.25. Minus 412.09 minus 289. We get 421.16. Divide those two numbers on our calculator. Divide those two numbers on our calculator. Divide it by negative, so 421.16 divided by 690.2, negative 690.2, I get negative 0.610199942. All right, and then we're going to take the inverse cos of that angle. So theta is equal to, theta is equal to the inverse cos of that number theta is equal to, so the inverse cos of second function answer, and I get 127.60, 127.603, and so on. It's said to the nearest tenth of a degree, so theta is equal to 127.6 degrees. Determine the measure of the angle for the roof cap. The angle for the measure of the roof cap is 127.6 degrees. And that is it for this section. So there's some homework questions to go along with that. They can be found on page 171, number 2, 3AC, 4, 5, and 7 through 13. And that is it for this video. I hope the videos are helping you. And that's it for section 4.2. Thanks for watching, everyone, and we'll talk again soon.